use of limited range of T equations. T equations means trigonometric equations. So these T equations are in the form of A sin x plus or minus B cos x. So what will be the range of these kind of T equations which we have already discussed? That is, the range will be minus under root a square plus b square to plus under root a square plus b square. So there is nothing much to teach in this topic. So let's directly solve few questions so that you'll get a better idea how to approach the questions. In this question, we need to find the value of a for which the equation which is given has a solution, which means first we need to find the solution of this equation for which the value of a exists. So first let's solve the solution for x, that is a square minus 2a plus secant square pi into a plus x is equal to 0. Now this kind of equation can be solved using the completing square method. This is a method which we have already learned in the quadratic equation chapter. Here we need to add and subtract values so that we can make a complete square. Like we need to add and subtract 1 so that it gives a complete square. Like from here we can write it as a minus 1 whole square, and secant square theta minus 1 is tan square theta. So theta is nothing but pi into a plus x. So these are the two square terms, right? Square in the sense the value for this will be greater than or equal to 0. The range for this will be greater than or equal to 0. So to get 0, what should be the values of these two? So only one case is possible, that is both the values should be equal to 0, right? Then only it satisfies the RHS part. So solve this, you will get it as a equal to 1 over here. Substitute this value of a here, you will get it as tan square pi 1 plus x is equal to 0. Now you can solve this to get the solutions for x. But in the question, it is asked only the value of a. So here we don't have any a variable. So this is the required answer or the required value of a for this given equation. In this question, it is given an equation and it is told the theta lies between 0 and 4 pi and x belongs to all the real numbers, and we need to see which option is correct from these four. So let's see the LHS part of the equation, which is nothing but sine theta plus root 3 cos theta. Let's first find the range of this equation. For these kind of equations, what will be the range? We have already discussed, that is minus under root a square plus b square. Here a is 1 and b is root 3. It becomes 1 plus root 3 whole square is 3 to plus of 1 plus 3, which is nothing but minus 2 to plus 2. So this is the range of the LHS part. Now let's see the RHS, which is 6x minus x square minus 11. So in this, take minus common. It becomes x square minus 6x plus 11. This 11 we can split it as x square minus 6x plus 9 plus 2. Why plus 9 plus 2? Because if you observe, if you think about the next step, here x square minus 6x plus 9 is nothing but x minus 3 whole square. So we can write it here, x minus 3 whole square plus 2 equal to 0, and this can be written as minus x minus 3 whole square plus, sorry, minus 2. Now, to this equation, what will be the range be? If you see, so here, if x is 0, it will be minus 2. If you keep x is equal to 1, it is 1 minus 3, which is 2 square 4 minus 6. If you keep x is equal to minus 1, it is minus 16, minus 2, minus 18. So if you observe, this is only the highest number when x is 0 and remaining all are less than these. So if you observe in a number line, here it is minus 2 and here it is 2. So LHS part is this much, which lies in the range minus 2, 2 and 2. Both are including over here. This is LHS. And RHS is minus 2 to infinity, minus infinity. Here minus 2 is also included. So and this is RHS part, which is nothing but minus infinity to minus 2. So the only common point over here is minus 2. So just we'll equate the RHS with this minus 2 and let's see what happens. So equate this value with minus 2, that is minus of x minus 3 whole square minus 2 equal to minus 2. From here we can get it as x is equal to 3. So we'll have just one value of x. So if you see options now itself, here it is given as no value of x, but this is not the correct. We will have one value of x. If you see the next value, if you see the next option, which is two pairs of values of x comma theta. Till now we didn't find the theta, so we can't judge this option. Next, it's two values of x, which is wrong. So either the answer might be B or D. So let's solve for theta now. Now equate LHS with minus 2 so that you'll get the solutions for theta. So sine theta plus root 3 cos theta is equal to minus 2. Divide it, you'll get it as 1 by 2 sine theta plus root 3 by 2 cos theta equal to minus 1. So write in terms of sine and cos over here. So here 1 by 2 is nothing but sine pi by 6 and root 3 by 2 is cos pi by 6. So it's in the form of cos A cos B into cos A cos B plus sin A sin B. So which is nothing but cos of A minus B, that is theta minus pi by 6 equal to minus 1. So now this is in the form of simple T equation. So we can write the general solution for this, which is nothing but theta minus pi by 6 is equal to 2n plus 1 into pi, where n belongs to all the integers. From here, theta becomes 2n plus 1 into pi plus pi by 6. But in the question, the range is given, that is 0 to 4 pi. So let's find the values of theta in the given range. So range is 0 comma 4 pi. If you keep n is 0, then theta will be pi plus pi by 6 and this lies in the range. Okay, next if you keep n equal to 1, theta will be 3 pi plus pi by 6. This also lies in the range. But if you keep either minus 1 or the value more than 1, it doesn't lies in the range. So we will have two values of theta, that is theta equal to pi plus pi by 6 and 3 pi plus pi by 6. And from here we can make the pairs of x comma theta, that is X is 3, theta is pi plus pi by 6. This is one pair, and the other pair is 3 comma 3 pi plus pi by 6. So we'll have two pairs of x comma theta. So if you see the options back, B option will be the correct answer to this question. And D is incorrect because we'll have two values of theta, not the only one value. So B option is the required answer to this question. In this question, it is given if x and y are the solutions of the equation. And this is the equation. This equation, which we have already discussed in the earlier question, that is on the LHS side we have trigonometric ratios, and on the RHS side we have quadratic expression. So we need to find the value of this. So to find the value of this, first we need to find the value of x and y. So to find that, first we need to find the range of LHS and RHS separately. So to do that, the LHS will be 12 sin x plus 5 cos x. What will be the range of this? The range will be minus under root 12 square plus 5 square to plus under root 12 square plus 5 square, which is nothing but minus 13 to plus 13. Coming to the RHS part, I'm taking 2 common, so that inside it becomes y square minus 4y plus 21 outside. So to make it a perfect square inside, we can add and subtract 4. So it becomes y square minus 4y plus 4 minus 4 plus 21, which is nothing but 2 times of y minus 2 whole square minus 4 plus 21, which is nothing but 2y minus 2 whole square minus 8 plus 21 is nothing but plus 13. So for this, what will be the range be? So for this thing, if y is 0, the value will be 13. Either if y is 1, the value will be 2 plus 13, 15. If y is minus 1, the value will be 3 square 9 to the 18 plus 13, which is 31. So the least value is 13, and highest value increases as the value of y increase, either decrease. So the range becomes 13 to infinity included. So if you see on the number line, which is minus 13 to plus 13, the LHS range is nothing but till minus 13 to plus 13, and RHS range is plus 13 to infinite. So the common point over here is plus 13. So equate the RHS with 13, you will get it as 2 into y minus 2 whole square plus 13 equal to 13. From here, you can write y equal to 0. So we got the solution for y. Now we need to get the solution of x. So to get that, we need to substitute. We need to equate LHS with 13. So it becomes 12 sin x plus 5 cos x is equal to 13, and it becomes 12 by 13 sin x plus 5 by 13 cos x is equal to 1. So now if you assume a triangle, and this is alpha, and assume this 12 by 13 as sine alpha, then here in this triangle it will be 12 over here and 13 as hypotenuse, and this will be 5. So this can be written as cos alpha. Now it's in the form of sin A sin B plus cos A cos B. So cos A minus B, which is x minus alpha equal to 1. So this is a simple t equation. The general solution will be x minus alpha equal to 2n pi and x is equal to 2n pi plus alpha, where n belongs to all the integers. So we got the value of x also, and we also have the value of y. So now we need to find the value of this, which is given in the question. So just substitute the values of x and y over here. So we can write it as 24 by 5 cot xy upon 2. So this is nothing but 24 by 5 cot x is 2n pi plus alpha, y is 2 upon 2. 2 gets cancelled, and cot 2n pi plus alpha is nothing but cot alpha. From this triangle, find out the cot alpha value. Cot alpha is nothing but cos upon sine. Cos we already got 5 by 13. Sine is 12 by 13. So it will be 5 by 12. So just substitute 24 by 5 into 5 by 12. This gets cancelled, and this is twice of this. Therefore, the value 24 cot xy upon 2 is 2. This is the required answer to this question.